Hello, have a good day. This is the ninth homework of the algorithm design and analysis. And in here, the topic is dynamic programming. And from the book, the dynamic programming is like divide and conquer method solves problems by combining the solutions to subproblems and solve the subproblems recursively and to combine their solutions to solve the original problem. In contrast, dynamic programming applies when the subproblems overlap. That is, when problems share subproblems. In this content, a divide and conquer algorithm does more work than necessary repeatedly solving the common subproblems. A dynamic programming algorithm solves each subproblems just once and then save its answer in a table, terribly avoiding the work of recomputing the answer every time it solves each subproblem. It's just we can think like this one. Uh, we have a problem, and the biggest element of this problem is relating with the other sub solutions, the other answers. It's based on the cumulative problems. And dynamic programming typically applies to optimization problems. Such problems can have many possible solutions. Each solution has a value, and you want to find a solution with the optimal value. We call such a solution an optimal solution to problem as opposed to the optimal solution, since there are maybe several solutions to achieve the optimal value. To develop a dynamic programming algorithm, there's a sequence of first steps. The first of all, the characters the structure of an optimal solution. The second, recursively define the value of an optimal solution. And third of it, compute the value of an optimal solution, typically in a bottom-up fashion. The last of it, the construct an optimal solution from computed information. And steps 1 to 3 form the basis of dynamic programming solution to a problem. If you need to only the value of an optimal solution and not the solution itself, then you can omit step 4. When you do perform step 4, it often pays a maintain additional information during the step 3 so that you can easily construct an optimal solution. The section that follows uses the dynamic programming method to solve some optimization problems. And the problem of cutting a road into the roads of smaller length in a way that maximizes their total value. And is there, yeah, it's basically like this one. And okay, there is a, we can think like this one. This is A, this is the answer, and this is AA, and this is 3A, 4A. If we can calculate the first A, then we can multiply it this one, then we can multiply with this one, and it goes on. It's kind of recursive, and the in the solution in here based on the other solutions. So we can calculate this one and save it in another value, like let's assume the result is B, then this is will be something B plus X or F, and let's assume it's F1, and this will be F2, and F2 will be based on the F1, and in here F3 will be based on F2 and also F1 because F2 is based on the F1. So let's ask the let's take the question from ChatGPT. Sorry. The or question is okay. Here's a basic dynamic programming practice question. The Fibonacci seconds of defined as follows. Write a dynamic programming function to calculate the nth Fibonacci number efficiently. Implement the both recursion and dynamic programming bottom-up or memorization solution. For example, if n equals 5, the Fibonacci sequence is 0, 1, 1, 2, 3, 5. So the output should be 5. Feel free to provide both recursive and dynamic programming solutions in your response. Okay, actually, this is the same as we did in the lecture. So I will start to writing calls with defining a function, Fibonacci function. This will take the nth and okay, the Fibonacci. I'll just write a fib, and this is 0, the first element, and we'll multiply m plus 1. Okay, we have base cases for uh, 0th element. 1, 2, 3, 4, 5. Okay, we have 0 element, and we have the first element. The 0 element will be equal to 0, and the first element will be equal to 1, and the second will be equal to 1 actually, because it will calculate 0 plus 1 will be equal to 1. So actually this is not the base case for us, because we have 0 and 1 element. So with calculating this one, we can find the second element. So for the first cases, Fibonacci 0 will be equal to 0, and Fibonacci 1 will be equal to 1. So with this information we can find the second, so I will not write this down. And for every element in a given number of n, it will starting from the second, because there are given 0 on the ones. So I'm just going to dive into the 2 and then plus 1. Also, actually, if we write here as Fibonacci second number, we can just go dive into with the 3. It will be saving the answers. It will just or array will save the answers, so there's no need. Fibonacci I will be equal to Fibonacci number, the e minus 1 element plus Fibonacci I minus 2 element, and it will return Fibonacci n, and I made any mistakes. I guess I haven't. Here the results will be equal Fibonacci n, and I have to print the result. Yep. And Fibonacci number is result. Yep. Okay. Undefined name, and okay, let me check. Oh, okay, yeah. I forgot to take an input, and let's be equal 10. Yeah, this n is or input in here, input in here, and this must be working. Actually, it is working like this one. Let me open here, and let me draw it like this one, and this is 0, 1, and this is the 0th element, and the answer is 0, 1. We are calculate summing up 0 plus 1 will be 1 in here, and this is our second element. So when we go dive into the tree, we have to calculate, okay, this is 3 minus 1. Actually, how I can write 3 number plus, yeah, okay, let me take it back, and uh where's the, okay, anyway, okay, let's like this one, 0, okay, this is 0 and 1, okay, this is 0 and 1, this is a 0th element and first element, and this is our base case. Within this one we can sum up 0 plus 1 will equal 1, so this is 1 and this is second. We can calculate the second with based on 0 and 1. So if we go dive into the tree, we have to 3 plus 1 element plus 3 minus 2 element, so this will be equal second plus first element. So 1 plus 1 will be equal 2, and if we go for the fourth of it, it will be same, 4 minus 1 plus 4 minus 2, so this will be equal 3 third element and second element, so it will be equal 2 plus 1, so it will be just 3 in the fourth element. It's just going like this one. We have the base cases in here, and whenever we find any solutions, it will be saving in our array. So let me run this. Okay, the 10th number Fibonacci is 55. Okay, let me write a, okay, there's a 5, and okay, let me write 8 like this one, and in the ChatGPT it's n equal 5, n equal 5 is given as 5. So let me ask if the 5 is this true. Let me check. This is 5, it is true. So if we go for the n equal for, okay, let me write this one, n equal 6, it must have to be 3 plus 5, so it will have to have equal to 8. Let me check for that one too. Yeah, this is true, and let's ask the ChatGPT, is this true or not? Yeah, my solution is this. Can you check is this true or not? Let me resize it. Okay, yes, your solution looks correct for finding the nth Fibonacci number using dynamic programming. You have correctly initialized an array fib to store intermediate results and iteratively filled it up to calculate the Fibonacci number up to n. This approach is more efficient than a naive recursive solution, especially for larger values of n, as it avails redundant computation by storing previously calculated Fibonacci numbers. Your implementation correct returns the sixth Fibonacci number as 8, which is consistent Fibonacci sequence. So well done. If you have any more question, or if you want, okay, this is true solution, and in here for the there was something to, yeah, okay, in naive recursive solution is just it's calculating one by one. In here, where's my paint, it's just calculating 0 1 2 3 4, but it is not saving. So When you have to find the fifth value, you have to recalculate the fourth value and third value because it's not a saving in an array. And thanks for the listening. Have a good day.